Good afternoon, chemistry students. Here's today's video lesson. You're going to need these two pieces of paper here. This one you did in class yesterday for part of your lab, and then this one that substitute's handing out today. So what are we working on here? We're working on converting from one unit to another using dimensional analysis. And this lesson is designed to help you understand this lesson and future chemistry lessons. This is just in general on the topic of dimensional analysis. So what you're going to be looking at is a series of fractions, and these are called conversion factors. So every conversion factor can be expressed as a ratio of two parts of the statement that relates the units, called equivalent statements. So, for example, 1 mile is 1.6 kilometers. That's an equivalent statement. And there's two ways we could express it. 1 mile over 1.6093 kilometers, or 1.6 kilometers over 1 mile. You can do it either way. Each of those are an equivalent statement. You might be wondering, well, how about if we want to know how many miles was in 1 kilometer instead of how many kilometers in 1 mile? We could just use simple ratios. We could do 1 mile is to 1.6093 kilometers. I'll just stop at the 9. That's kilometers, is equal to, now, x miles over 1 kilometer. And so once we find that x by cross-multiplying and dividing, we'll have another way to write the equivalency statement. So 1 times 1 divided by 1.609 gives us an x of 0.621 miles. So we can write the equivalency statement then as 1 kilometer equals 0.621 miles. So again, these two are the same. They are just reciprocals of each other. So let's write this as two conversion factors or equivalency statements. So here's our conversion factor. We're going to take this statement and we're just going to write it as a fraction. So 1 kilometer over 0.621 miles. And how else can we write this? We can put 0.621 miles over 1 kilometer. Let's do one more. 1 quart, 1 QT is 32 fluid ounces, or 32 fluid ounces is 1 quart. So these conversion factors that came from these equivalency statements can help us change kilometers into miles, or quarts into ounces, or ounces into quarts. You can go either way. Which one do we use though? If we want to go from kilometers to miles, which one do we use? If we want to go from miles to kilometers, which one do we use? Down here, if we want to change quarts into fluid ounces, or fluid ounces into quarts, we have to pick the right conversion factor. Why don't you take a minute and write these next 3 as conversion factors. So just write them as fractions, just like I did here. So take a minute to do that, and I'll assume you've done that now. Probably stop the video to do that. So let's go ahead and move on now. So now we're going to use some conversion factors like this to answer some questions down below. And along the way, I've given you some equivalency statements like this one, these here. And on the back side, you'll see some here. Here's another one here. So just be looking for those. Okay, so in this first one, a straw holds 7 milliliters of water. It says convert the straw volume to liters. So we want to convert milliliters to liters. And I think before we do that, I want to take a minute. I want to show you something else here before we dig in here. I want to show you this paper here. Okay. So dimensional analysis, it's how to go from one unit to another unit. So let's say we want 3 dozen eggs. And let's say 1 dozen eggs is $2.19. How much does 3 dozen eggs cost? Well, we know an equivalency statement right here can be written as this conversion factor or this conversion factor, just like you were doing just now over here. So which conversion factor do we use to change 3 dozen eggs into dollars? That's what we want to know. We want to know the cost. Well, it probably makes sense to you that you're going to put the $2.19 on the top and the dozen on the bottom. Those will cancel, and that will leave you your answer in dollars, which is, let's see here, 3 times 2.19 equals 6.57. $6.57. It doesn't make sense to do it this way. 3 dozen times 1 dozen per 219, that gives us 3 divided by 219, 3 divided by 2.19 equals 1.37, and that's dozen eggs squared over dollars. That doesn't make sense. If 1 dozen costs $2.19, we know it has to be in the range of $6. So that was the wrong equivalency statement to use. Conversion factor. The equivalency statement is here. The conversion factors are the fractions you use to solve your answer. So this right here is really the key to all the problems you're going to do. So pay real close attention to this. So the whole idea of dimensional analysis is to go from one unit to some new unit, an old unit to a new unit. And to do that, you're going to multiply always by the new unit on top, the unit you want to go to. And you want to divide by the unit that you just started from. So to the new unit and from the old unit. So here we started with eggs, dozen eggs. So we want dozen eggs on the bottom, the old unit. And we want what we're trying to get to, dollars on top. That's $2.19. So you're always starting in one place. You're trying to get to a new place. And you always multiply by what you want to get to, the new unit, by what you're coming from, the old unit. Okay? So to and from. All right, so let's use what we just learned there to answer this next set of questions now. So convert a straw that holds 7 milliliters of water into liters of water. How many liters is that? So where are we starting? We're starting with the old unit, 7 milliliters. And what are we trying to get to? We're trying to get 2 liters. So we want to multiply what we're trying to get to, liters on top, divided by what we're moving away from, what we're trying to cancel, milliliters. And what's the relationship between liters and milliliters? 1 liter is 1,000 milliliters. 1 liter is 1,000 milliliters. So there's our equivalency statement, and here's how we're going to use it as a conversion factor. We want liters on top, that's what we want, and we're trying to cancel milliliters. And that would give us 0.007 liters. Okay. So the next question now is how to convert your answer to problem 1 into kilograms. So how do we change that into kilograms? Well, if you knew the relationship between liters and kilograms, this would be an easy one-step process. We just take our answer here and we change it to kilograms. But I don't see that here anywhere, and I haven't taught you that. What I have taught you, though, you learned this with metrics right at the beginning, is that 1 milliliter of water has a mass of 1 gram. And once we know the grams, then we can change that to kilograms because we learned that there are 1,000 grams in a kilogram. So where are we starting? We're going to start with 7 milliliters. And where are we going to? What are we trying to get to? We're trying to get to kilograms. But in between, we have to change to grams first. So we're going to change milliliters to grams, and then we can change grams into kilograms. So 7 milliliters times 1 gram per milliliter. Notice I'm multiplying by what I'm trying to get to, what I want on top, grams, and then dividing what I'm moving away from, the milliliters. And now I'll take that and multiply it by 1 kilogram per 1,000 grams. Again, I'm trying to get to kilograms. I had to take an intermediate stop at grams first, so from milliliters to grams and grams to kilograms. And in each case, I'm dividing by the unit I'm trying to move away from. And so on my calculator, I would type 7 times 1 divided by 1 times 1 divided by 1,000. And of course, you know that timesing by 1 and dividing by 1 doesn't really do anything. So in this case, we can just do 7 divided by 1,000, or 0.007 kilograms. Well, it turns out then that a liter happens to be 1 kilogram in mass. Okay, so if you knew that, you could have just taken this answer and multiplied by, you could have done 0.007 liters and just multiplied by 1 kilogram per 1 liter. And then that would just give you the answer, again, 0.007 kilograms. Okay. Down here in this problem, it says express 2.37 cups as milliliters. Solve the problem twice using both equivalencies provided. So you're going to use this one, and you're going to use this one. Notice what I did. I gave you 1 cup, tells you how many milliliters, and here 1 milliliter is how many cups. So these two are the reciprocals of each other. All right, so use those two equivalencies to solve the problem 2 different ways. When you're finished, you should have the same answer for both of these. So here's your equivalency statement here. You can use this one here and this one over here, or switch them around. I don't really care. So go ahead and find out how many milliliters 2.37 cups is. Solve the problem twice using both equivalencies. And I'll assume you're stopping the video and you're doing those problems, and then you're moving on to the back side. So on the back side, we're asked to, let's see, we're given some equivalency statements that we can write as conversion factors. We can write them as fractions. And let's see what we're trying to do. The mass of a paperclip is 0.96 grams. Okay, so how many kilograms is that? Well, you should know. Let's see, I don't have it on here, but, well, there it is right there. We learned this in metrics that there's 1,000 grams in 1 kilogram. So where are we starting? 0.96 grams. And we're trying to change that into kilograms. So we multiply what we're moving to, what we want on top, kilograms. And we're dividing by what we're trying to move away from, grams. Always to and from. So 1 kilogram is 1,000 grams. We fill that in, and now we can cancel. And that gives us our answer. This is kind of a silly answer, 0.00096. So that's not very many grams. Obviously, a paperclip is very small, and a kilogram is quite big, 2.2 pounds in 1 kilogram. So we get a really small answer here. Now we want to convert that to pounds. Well, I just mentioned that 1 kilogram is 2.2 pounds. So use that to change this answer into pounds. So you're going to change this answer here into pounds using that equivalency statement. Go ahead and stop the video for a minute and give that a try. Okay, I'll assume you've given it a try. 0.00096 kilograms. And now we're going to multiply that by what we want on top, what we're trying to get to. What we're trying to get to is pounds, 2.2 pounds. And we divide by what we're moving away from, kilograms. And there's 1 kilogram and 2.2 pounds. So we don't want these numbers flipped over. We don't want 1 over 2.2. Here the 1 was on top. No, here we want the 1 on the bottom because we're trying to move away from kilograms and 2 pounds. So we're going to take that last answer and multiply that by 2.2. 0.00096 times 2.2. And that gives me 0.002112 pounds, because the kilograms canceled. Now we're going to convert that to ounces. So once again, take your pounds here and change it into ounces using this equivalency statement. Stop the video, take a minute to do that. Okay, you're probably back live, and now we're going to do the problem here is 0.002112 pounds, and we're going to change that into ounces. What do we want? What are we trying to move to? What are we moving to? We're moving to ounces, and we're moving away from pounds. So ounces has to go over pounds. How many ounces per pound? 16 ounces for every 1 pound. And so we're taking that answer and multiplying by 16. And that gives 0.33. I'll just round it out there, 0.338. All right, so hopefully you were able to do those two. Now what I want you to see is how you can do, let's say I asked you to change 0.96 grams into ounces. Could you do it all in one problem rather than 3 separate problems? The answer is yes, you can. And so that's what I'm going to show you here. And eventually, this is the kind of dimensional analysis we like to be able to do, is to do multi-step problems all embedded in one problem. So this is what it's going to look like now. I'm going to start with my 0.96 grams. And I'm going to change that to kilograms by multiplying by 1 kilogram over 1,000 grams. Okay, and then I'm going to multiply that by 2.2 pounds, because I want to move from kilograms to pounds so that I can change pounds into ounces. 2.2 pounds over 1 kilogram. And doing this now, that changes my grams. I forgot to write grams there. That changes grams into kilograms. And now this changes kilograms into pounds. And finally now, I'm going to change pounds into ounces. I'm trying to move away from pounds. I want to cancel the pounds, and I'm going to move 2 ounces, 16 ounces for every 1 pound. And so when we do this now on our calculator, we do 0.96 divided by 1,000 times 2.2 times 16, and we get our answer once again, 0.338. The idea is that we did this in one series of steps, embedded all into one problem rather than 3 separate problems. The next one is to convert tons to pounds. And so I think let's just skip this one. Okay, let's move on to this next set here. I'd like you to do this set as homework, so I'm not going to show you the answers for these. These will be your homework. And you're starting with kilometers, or with this equivalency statement that you can turn into fractions for conversion factors. So start by measuring the length of your foot in centimeters. Okay, it turns out there's about 30 centimeters in a foot. So if you have, if you don't have a ruler in centimeters, just take a guess. Again, there's about 30 centimeters in 1 foot. So, or maybe 30 centimeters equals 12 inches. Maybe we'll do it that way. And so figure out how long your foot is, and you can write that there. And then, I guess you don't write it there. Just measure your foot, and then let's see if you can convert it to meters, kilometers, and miles. Okay, so that one you're going to do on your own. Okay, this next one I want to show you is it's a problem that gives us several equivalencies in it, and we're going to use those equivalencies. We're going to unpack this problem, and we're going to use the equivalencies in it to try to solve the problem. The problem is, how many pallets of boxes can Charlie fold in 1 hour? That's essentially the question. So we're starting here. That's where we're starting, and we're trying to get to here. So what we want to know is how many boxes Charlie can fold, We're trying to figure out how many pallets of boxes Charlie can fold in 1 hour. And this is what we're starting with then, 1 hour. Okay, so I'm going to write 1 hour. And I know some other equivalencies here. I know 38 seconds to fold 1 box. So I'm going to write that up there. 38 seconds per 1 box. And I know that 1 pallet holds 64 boxes. These conversion factors are going to help me move from 1 hour into how many pallets of boxes Charlie can fold. But I'm not given how many boxes he can fold in an hour. I'm given boxes he can fold in 1 second. So really what I want to do to get to the number of pallets is I want to figure out how many seconds that is, 1 hour, and then I can use these equivalency statements to figure out how many pallets Charlie can fold in 1 hour. So I'm going to multiply by 60 minutes per 1 hour, and I'm going to multiply by 60 seconds per 1 minute, and that will give me the number of seconds. So hours cancels hours, minutes cancels minutes, and I'm left with how many seconds. Once I know that, then I can figure out how many boxes Charlie can fold in 1 hour using this equivalency statement. And once I know how many boxes, I can figure out how many pallets that is. So I've changed from hours to seconds, and now I can change this answer into boxes by multiplying by 1 box every 38 seconds. Now seconds cancels seconds, and I'm left with how many boxes. So if I do 1 times 60 divided by 38, I'll know how many boxes. But I want to do this in one continuous problem. So I'm not going to find my answer. I'm just going to keep working. And now I'm going to multiply it by, let's see, should I do 64 over 1 or 1 over 64? Well, I want to get rid of boxes, so boxes has to go on the bottom. And I want to move 2 pallets. So 1 pallet for every 64 boxes. So now I can solve the problem. Again, the ones I really don't need to use. 1 times 60 is still 60, and 60 divided by 1 is still 60. So I can ignore all the ones. So really, all I have to do here now is 60 times 60 divided by 38 divided by 64 equals 1.48 pallets Charlie can fold in 1 hour. Again, boxes cancels boxes up here. There we go. So now I'm left with how many pallets Charlie can fold, how many pallets of boxes Charlie can fold in 1 hour. All right. This problem here is a little wonky and a little bit different. I'm just going to cross this one out. Don't do this one. Not to worry about this one. So your goal right now is to finish this, if you haven't done it, and to finish this. And then you're going to turn that in tomorrow. And then if you'd like to do some extra credit, you can do this right here. Okay. Notice it says make me laugh, not cringe. Okay. So try to keep this, well, you know, high school. I don't know if that's PG, what high school is, but, you know, try to keep it high school appropriate. And I'm going to show you a few examples of some student work in the past. I'm going to show you the high school appropriate versions. I'll start with this one right here. This one was written by Sydney Morris. And by the way, these papers, the students have told me that I can use. So I want to show you what Sydney has done. So her question is, how much money do the guys in the universe spend on roses on Valentine's Day? Now you can, when you do this, you can do something a little crazy like this. You know, maybe you only believe there's one planet with people on it, Earth, or maybe you believe that there are guys on other planets. So if you're like Sydney, she's, you know, getting a little fun here with pretending there are other worlds. So she didn't write down her equivalency statements. I'd really like you to do that. So hopefully she would write something like, there are 12 roses purchased by each guy on Valentine's Day. And then another statement would be there's 150, 1.5 million guys per one country, and there's 150 countries per world, and there's 5 worlds per universe. So when you multiply all that out, notice roses over here cancels roses because it's $20 per roses. And by the way, you notice she didn't use the $20 per roses next. She did that at the end, and that's okay. Here, guys cancels guys, countries cancels countries, world cancels worlds, and roses again cancels roses. So we're left with dollars per universe. And so that's how much all the guys in the universe spend on roses for Valentine's Day. I don't buy roses for my wife on Valentine's Day. I buy her Alstramarium because that's our wedding flower. Okay, that was Sydney's. Let me show you another one. This one's very practical. So there's this crazy problem here. Let's see. You're throwing a pizza party for 15 people and each person wants 4 slices. How much will the pizza cost you? You call up Papa John's and you're told that each pizza will cost $14.78 and will be cut into 12 pieces. Unfortunately, you're broke, so you're not sure what you'll do. Do you have enough money? So she's given a bunch of equivalency statements up here, like 12 slices in one pizza and the cost for one pizza. So she happened to start with the cost, $14.78 per pizza, and she multiplied that by 1 pizza over 12 slices, so that cancels pizzas, 4 slices for each person, 15 persons or people per party. And when she does that, she's left with the dollars per party, $73.90. So that's another example. That one's very practical. Here's one here. Somebody figured out how many uniforms. Let's see, how many uniforms per school district. So I'll let you read through that. And I'm going to show you a couple others just for fun, real quick. This is my favorite. This is my favorite one ever written. This is by a guy named Stephen Bishop. How long would you have to lie on the ground before getting pooped on by a bird? And so he estimates, and I looked some of this stuff up, and he's about right. There are about 300 billion birds on our planet, and our planet is a sphere, so 4 pi r squared. That's the surface area of a sphere. 4 pi r squared, that's the radius of the Earth. And he multiplied that by 1 poop per bird per hour. That is, he's saying each bird poops 1 time each hour. and there are 24 hours in a day and 365 days in a year, and there's only one body that needs to be pooped on, and a body is approximately 0.75 meters squared. That's the upper half of your body, not the lower half, because the bird can only poop on the upper half of your body when you're laying down. And when he finishes his calculation, he comes up with about 94 and a half days. If you laid on the ground continuously for 94 and a half days, likely you'd be pooped on by a bird. Love it. This one here, I won't show you the calculation, but Cascade is a 4A school. There are 65 4A schools in Washington. Around 1,800 students go to Cascade for 6 hours. Each student writes and takes notes at an average of 40 words per minute. A pencil can write 40,000 words, and so on and so on. And so what he's trying to solve is every time 5 elk die, a gray wolf starves to death. Okay, so how many school days will it take to kill one wolf? So this is all based on, if we cut down trees to make pencils, then we kill habitat for elk, and that kills the elk the wolf like to eat. And so anyway, that was his problem. That's a public service announcement, by the way. Okay, so that's your extra credit if you want to do that. And now what I want to do is show you this one here. Okay, so hopefully you found that after watching the video, you learned that these masses on the periodic table are the masses for one atom in atomic mass units and the mass for one mole of atoms in grams. That is the mass for 6.02 times 10 to the 23rd atoms. If you had 6.02 times 10 to the 23rd atoms of copper, it would weigh 63.5 grams. Okay, so we're going to use that, and we're going to use this. And you're going to see this written up on the board on the far right-hand side of the classroom as you're looking forward. And that's going to stay up there until test day. And on test day, that's going to come down. But of course, you're going to write that in your notes. So you'll be able to use this. It's sort of like a road map. There are 3 towns: mass, volume, and particles. Unfortunately, there's no road that goes from volume to particles or volume to mass. The only way you can get to mass town from volume town is to go through mole town first. So mole is the central figure in all our calculations. Okay, we know one of those already. We just learned that 1 mole of any substance has a mass equal to the mass on the periodic table. So if you have 1 mole of copper, you simply multiply 1 times the molar mass times when you're going this way, and that would be 63.5 grams of copper. 63.5 per mole. If you had 2 moles, you just multiply 2 times 63.54 grams, and you'll have your answer for the mass for 2 moles. That's simple. Likewise, if you know the mass and you're trying to figure out how many moles, then you divide by the mass. So let's say you had 100 grams. So 100 grams of copper. And now we're going to multiply by 1 mole per every 63.5 grams. Actually, what we're doing, of course, is dividing. So 100 divided by 63.5. I think you can see it's more than 1, but less than 2. 100 divided by 63.5 equals 1.57 moles of copper. So we multiply by gram over moles when we're going this way, and we multiply by mole over gram when we're going this way. So we're really dividing by grams. That's why I wrote divide there. Okay? All right. So let's take a look at some of these problems on this page here. Okay. What was the mass of 1 mole of aluminum? Well, you just look that up on the periodic table, 26.98. And how many pop cans was that? I don't remember. It's been a while. I don't think we did this lesson last year during COVID because, well, we couldn't weigh things on a scale. But I'm going to guess it was 4 or 5 or 6 cans, something like that. Okay. And what is the mass of 1 mole of iron? So you just look that up on the periodic table. And hopefully then you put the nails on the scale until it got to 55.8. I don't know how many that was. And then how many nickels in 1 mole of nickels? Well, 1 mole of nickels is 1 mole of nickel is 58.6 grams. And I happen to know, it's really nice if you want to know how many grams something weighs. You can hold a nickel in your hand to get an approximation because they're almost exactly 5 grams for 1 nickel, right? Nickel's 5 cents, 5 grams. And so that should have given you an answer somewhere near 11 to 12 nickels. How many atoms in 1 mole of nickel? Well, that's easy. Remember, 1 mole of anything is 6.02 times 10 to the 23rd of those things. So that's how many atoms in 1 mole of nickel. Okay, but nickel is an element. It's not a compound. Sodium chloride is a compound. So if we want to know something about sodium chloride that has to do with a mole, we have to know the molar mass of the compound of the molecule of sodium chloride, or better said, formula unit. Okay, so when you're looking at this, notice it says molecules, formula units, and atoms. Remember, only things that are covalently bonded, only things that are made of nonmetal are molecules. The rest are repeating patterns of ions. And so if we want to simplify, we can call one simple unit of sodium chloride a formula unit. That is 1 sodium and 1 chloride together, even though they don't exist as together in 1-to-1, like one of each, and that's a molecule. No, it's a whole bunch of them, right? A repeating pattern. So how much is a formula unit of sodium chloride? If you look at the periodic table, 223, this is 22.99 something. I just rounded off to the nearest tenth, 23.0, and the chlorine is 35.5, so that's 58.5 grams for 1 mole of sodium chloride. How many tablespoons was that? I'm not sure. I'm going to guess you had a decent sized pile. How many formula units in 1 mole of salt? How many formula units? 1. 6.02 times 10 to the 23rd. That's 1 mole of anything, whether it's a formula unit or a molecule or individual atoms. Okay, how many atoms in 1 mole of salt? Okay, now this is the tricky part. If you have 1 mole of salt, you have 1 mole of sodium chloride. There are 2 atoms in that formula unit. So you would have in 1 mole of salt, 6.02 times 10 to the 23rd formula units. Yeah, go ahead and laugh. Formula units times 2 atoms per FU. And so that gives 12.04 times 10 to the 23rd, or 1.204 times 10 to the 24th. Times 10 to the 24th. Okay? All right. On to the back side. What's the mass of 2 moles of water? Well, to do that, we have to know the mass of 1 mole of water. 1 mole of water has 2 hydrogens in it, and each hydrogen has a mass of 1. I rounded off again to the nearest tenth. So 2 times the mass of 1 plus the mass of oxygen is 16. So that gives us a total mass of 18 grams per mole for water. And then I'm going to multiply the 18 grams per mole times 2 moles, and that gives me 36 grams. Okay? What is the volume of 2 moles of water? Well, we know it's 36 grams, and we know that water is 1 milliliter per gram, so that's 36 milliliters. Okay, how many molecules in 2 moles of water? Well, first of all, we're starting with 2 moles, and so we want to figure out how many molecules. So we're going to multiply it by 6.02 times 10 to the 23rd molecules per 1 mole. And that will give us our answer here. I'll let you multiply that out. Again, it's going to be like we did here, all right? And then you take that answer, if you want to know how many atoms, and you multiply it by 3 atoms per 1 molecule. All right? All right. So I'd like you to finish this now, and I'd like you to turn this in along with the other paper tomorrow. So how many molecules in 1 mole of oxygen gas, O2, and this is at STP. And if you're not sure what that means, I'll tell you about that when I come back. It means standard temperature and pressure. So obviously gases expand when they get warmer, and they get compressed if we squeeze them, if we add pressure. So if you're at standard temperature and standard pressure, then what is the volume for 1 mole of any gas? 22.4 liters. All right, so what do you do here? How many molecules and what's the volume? So, well, 1 mole is how many molecules? That's easy, right? How many items in 1 mole of anything? Right? And what would the volume be? All right? Just try to use your fractions when you're doing that, okay? Right? Try to write it as a fraction like this. And like these, okay? And then how many atoms are in 1 mole of oxygen gas? Hint. Once you know how many molecules of O2, you should be able to figure out how many atoms of oxygen, right? Because oxygen gas is not simple atoms of oxygen, it's molecules of O2, right? Okay, and then finally, how many atoms are in 67.5 liters of oxygen gas? So here's your 2. You want to know how many atoms, and you're coming from 67.5, so that's where you start. So you're starting with 67.5 liters. You're going to change that to moles. Then you're going to change that to molecules. Then you're going to change that to atoms. So that's a 4-step problem, I guess, or a 3-step problem. First, you're going to change from moles to liters. Let's see, is that right? I'm sorry, from liters to moles, and then moles to molecules, and then molecules to atoms. How many atoms? 2 atoms per molecule. So hopefully you can write that as one big problem. There you go. I hope this helps. And of course, I plan on being back tomorrow. I'm feeling much better this afternoon, and I should be ready to go tomorrow to help you out with this. I'm supposed to be at a training tomorrow, but I think it's best that I was in the classroom, so I've asked for forgiveness, and hopefully they realize that you are more important than the curriculum we are teaching. Bye.